One of the more serious issues impacting the ocean today is acidification. Ocean acidification is a problem that has come to light over recent years, along with the discovery and exacerbation of greenhouse gas emissions. Ocean acidification is the process by which the pH level of the ocean seawater is decreased, which translates to an increase in overall acidity. The main compound contributing to ocean acidification is carbon dioxide, currently constituting about 0.04% of the atmosphere. Despite its relatively small concentration, CO2 is a potent greenhouse gas and plays a vital role in regulating Earth's surface temperature and the acidity of the ocean. The reason ocean acidity increases concurrently with atmospheric CO2 levels is a result of a chemical reaction dissolving CO2 in the surface ocean. The emitted carbon dioxide doesn't just stay in the atmosphere. Roughly 30% is absorbed by the ocean. When CO2 reacts with water, it forms carbonic acid, which quickly releases a hydrogen ion, or H positive. The more hydrogen ions, the lower the pH, or the more acidic a solution is. As the ocean becomes more acidic, a number of negative impacts occur on the marine life, such as the bleaching of corals, as well as a number of proliferative and reproductive issues. So, using the data and research of the last few decades as a guide, now is the time to act and find a solution to this serious environmental issue. Answers using the perspectives of decoupling, whole system design, biomimicry, and resource productivity will be key factors when discussing plausible solutions to ocean acidification, with the major factor of anthropogenic CO2 emissions being the central theme behind them.
If we are going to tackle the issue of ocean acidification, we immediately need to recognize and understand the idea of decoupling, with regards to CO2 emissions and global and local economic growth. Decoupling from an eco-economic perspective is to separate the environmental pressure from economic growth over a given period. In other words, it is the development of economy without harming the environment. Relating decoupling to ocean acidification means to recognize the relationship between anthropogenic CO2 emissions and economic growth, both in Australia and around the globe. The solution to ocean acidification relies on the decoupling process of this relationship, resulting in a decrease in the rate of CO2 released in atmosphere. All solutions proposed in this video will assist with this decoupling, either on global or local scale, by reducing CO2 emissions, whilst fulfilling the economical gain required to progress as a population.
One of the main factors responsible for the increase in atmospheric carbon dioxide is the use of vehicles as transportation. According to a study released by the National Transport Commission, new cars in Australia produce 43% more CO2 than their counterparts in Europe. These results showed that cars produced 190 grams per kilometer, when the average of the European Union has mandated it at 130 grams per kilometer. However, research shows that the electric vehicle is the best choice to reduction of pollution due to the development of alternative battery combined with internal combustion engines, gas turbines, and fuel cells. The emissions of CO2 are proportional with the performance per kilometer for people mobility. The efficiency of the internal combustion engine can still increase somewhat over the next 10 years. In any case, yearly car emissions 4 to 5 tons of CO2 correspond to 4 to 5 times the mass of a 1,000 kilograms vehicle. Being more productive with resources and incorporate the use of older vehicle types such as the electric car is key to reducing these emissions and slowing the rate of ocean acidification.
Our system design approach, considering the relatedness of both problems and solutions, can help create more sustainable designs, especially in the area of environmental sustainable vehicles. An example of how whole system design can help to decrease the rate of CO2 emissions in the electric cars created in the UK. These cars have the potential to cut the oil imports by 40% and reduce drivers' fuel bills by 13 billion if deployed on a large scale, according to a new study. An electric vehicle would deliver an average of 1,000 of savings a year per driver and spark 47 drop in carbon emissions by 2030, said the Cambridge Econometrics study. The paper commissioned by the European Climate Foundation said that the air pollution such as nitrogen and particulates will be all eliminated by mid-century, with health benefits from reduced respiratory disease valued at over 1 billion. Also, the called green engineer has allowed the design of new processes for the manufacture of chemicals, foods, and products with a significantly reduced environmental footprint.
Another potential solution to ocean acidification that doesn't revolve around vehicles is designing power stations that don't burn fossil fuels or use another environmentally unfavorable methods to create and store energy. Biomimicry uses the biological view of animals, plants, and microbes as the engineers which can solve problems creating high-efficiency systems. Biomimicry has many solutions to decrease the rate of CO2 emissions and help to slow ocean acidification. An example of this includes the creation of sustainable energy systems using natural designs. To illustrate this, researchers developing a wind power system inspired by the pectoral fin of humpback whale that has been found to have incredible efficient aerodynamics. Whale's surprising dexterity is due mainly to its flippers, which have large, irregular-looking bumps called tubercles across their leading edges. This causes the water flowing past them to channel around the bumps, allowing the whales to keep their grip on the water during the sharp turning. Wind tunnel tests of model humpback fins with and without tubercles have demonstrated the aerodynamic improvements tubercles make, such as an 8% improvement in lift and 32% reduction in drag, as well as allowing for a 40% increase in angle of attack over smooth flippers before stalling. This slick, naturally occurring design can be directly engineered into eco-friendly energy harnessing designs such as wind turbines to maximize their efficiency and make them a more useful source power of energy, reducing CO2 emissions.